Okay, this video hopefully is an improvement on the last time I made this video. Um, so uh, I'm just going to talk about this page here. So when we've got a first earthquake and a second earthquake, and we want to know how many times stronger, um, because the Richter scale uses a logarithmic scale, we can use the powers, we can subtract the powers, and put them to the 10th power, because when we're dealing with logs in a general situation, it's usually base 10. So to figure out how much stronger, we subtract the Richter scale quantities, and then we do 10 to that power, and that tells us how many times stronger. So what kind of situations are used for a logarithmic model? Earthquakes, pH of water, sound frequencies, and such. Okay, so now let's talk about some examples that that you might see on the IB test or on your test. So the first thing we're going to do is we've got this question here: the magnitude of an earthquake which releases energy is given with this equation. So, so if we're talking about energy, and E represents energy, and they've told us that the energy given is this, and they want you to find the magnitude. Okay, we're trying to find the magnitude. So for question A, we're just going to use this equation and find M. So M is equal to 2/3 log to the power of 4.8, and E, oh gosh, I should have, this is 5.1 times 10 to the power of 10. Okay, that's this value here. So we plug it into the calculator, and some people were having difficulty doing this, so I'm going to show you on my calculator what exactly. Okay, so okay, you could just plug all of this directly into the calculator. 2 divided by 3, or let's just log 5.1 times 10 to the power of 10 divided by 10 to the power of 4.8. Close parentheses, and then we have to multiply that times 2/3, and your answer should be M equals 3.94. Okay, and that is the magnitude of the earthquake. For question B, it's a little trickier. Question B, how much energy is released? And they've given you that the magnitude is 4.3. So we know the magnitude is 4.3. So we've got 4.3 equals 2/3 times log E divided by 10 to the power of 4.8. Okay. So we want to get rid of the 2/3 first. So the first thing I'm going to do is I'm going to multiply 3/2 on both sides. 3/2, both sides of the equation. So I've got 3/2 times 4.3 equals 2/3 log E over 10 to the power of 4.8. Okay, and so that's going to make this 2/3 cancel out with a 3/2. And so now I need to multiply. So I'm getting this so that, because we want, if I've got a to the power of b equals c, we want to be able to convert this to a log form. We got a log form, we're going to convert it to exponential form. And if I'm converting to log form, we have log base a, my argument is c, and that's equal to the exponent. So let me just back up. Okay, we're given the log form. We want to convert it to exponential form. This will help us get our variable e outside of the log. So we're going to convert it to this form in just a second. But we needed to get rid of this 2/3 first. Okay, so now I've got 3/2 times 4.3. 3 divided by 2 times 4.3, and I'm going to get 6.45. So now I've got 6.45 equals log e over 10 to the power of 4.8. Okay. Now notice there's no base written here, so by default that means there's 10. Okay. So now I'm going to rewrite this in exponential form. Okay. So my base here is going to be 10. So I've got 10 to the power. My exponent is going to be this, 10 to the power of 6.45 equals the argument, which is this, which is e divided by 10 to the power of 4.8. Okay, so let's just look up here. If I had my base of 10, that's now my exponent base. Here, this yellow value is my argument in the log form. That now becomes what it's equal to. And in this here, the exponent is all by itself for the log, like right here, it's all by itself, and that now becomes the exponent. Okay, might help to write this conversion factor on your summary page before the test, and practice going back and forth. Okay, so we're almost done. We got to solve for e. So the next thing I need to do, if I multiply 10 to the power of 4.8 on both sides, or we could just say cross multiply, right? So then we get e is equal to 10 to the power of 6.45 times 10 to the power of 4.8. And if you got the bases the same, like this, then we can simply add those powers together, and I get e is equal to 10 to the power of 11.25, adding the 6.45 and the 4.8 together. And if I put that into my calculator, I get 10 to the power of 11.25, and we get 1.78 to the power of 11. Okay. Now, if you write 1.78 E11, I will not give you credit. 1.78 E11, that is not the correct answer. I won't give you credit for that. It would be 1.78 times 10 to the power of 11. Okay, so the next one works the same. Um, so let's see here. We've got m. Oh my gosh. M equals 2/3 log. The new power is 6.2 times 10 to the power of 13 over 10 to the power of 4.8. Plug that into your calculator, and you get m equals 5.99. During class, very few people had difficulty with finding A. So question B, I've got this all solved out on a different page. So I'm just going to put it up here. Okay, so they told you the magnitude of the earthquake is 5.1, so I'm replacing m with 5.1. We multiplied 3 over 2 on both sides. 3 over 2 times 5.1 gives me this value, and then I'm converting it to exponential form, so I have 10 to this power is going to be equal to the stuff in the parentheses. Then we multiplied 10 to the power of 4.8 on both sides. Then I could add the powers together, and then we simplify there. Okay, the pH question. Okay. So we've got this equation, and they've given you, question A, they've given you the pH. So it's pretty simple. You just put in 0.000234 in place of C, and then, so negative log this, and you get this in your calculator. Here, watch. Negative log 0.000234. Enter, and that's the answer. Okay, so finding the pH is easy. Now, if you want to get to the pH of 6.2, we need to figure out the concentration. So here I just rewrote the formula that we've got here. But to get rid of this log here, I'm just going to multiply both sides by a negative sign. So I have negative 6.2 equals log base 10c. So my base is 10, my exponent's going to be negative 6.2, and my argument is c. So I'm rewriting it in exponential form, and now it's really simple. I just put, I'm just going to put this as 10 to the power of negative 6.2, and I get my concentration as 6.31 times 10 to the negative 7. Okay. Make sure you do not write 6.31 e negative 7. If you write that on the test, I will not give you credit. Don't do it. Okay. Okay, I'm just going to talk through this one. And so they've said find the middle C. So to find the middle C, we're going to take this equation and we're going to make n equal to 0. Okay, so I'm making n equal to 0, and we just kind of plug it straight into the calculator. Well, actually, what did I do? We know that 10 to the power of 0 is going to equal this if I convert it to exponential form. And then anything to the 0 is 1, and then I can cross multiply, and I've got my x value. Okay, question B. Find how many octaves above the middle C is note with the frequency this. So the frequency is the f value of my equation. So I'm going to replace f with 784. Okay, and this is just simply plugging it into the equation. We didn't have to rearrange anything. We just replaced the letter F on this equation with 7, 8, 4. Okay. And then question C, find the frequency of the note 3 octaves above the middle. So now I'm replacing N with 3 in the equation. And so what I'm going to first do is I'm going to divide both sides by 3.322, which would have done here. And then 3 divided by 3.32 is going to give me this value here. And if there's no value here for log, my base is automatically 10. So now I'm going to rewrite this in exponential form. 10 to this power is going to give me equal to the stuff in the parentheses. And then I can multiply both sides by 261.6, and there we get the value of x. Okay, I hope that was helpful, and that's it for now.